back to Civil Engineering 24/7 YouTube channel. This is Adnan Ahmed, and in today's video short, this is a module number 2 where you will see the design of the compression members. Today we will go towards the second chapter. First chapter we took the introduction of design of steel structures with some various types of sections, various types of load considerations, various types of methods, LSM, WSM. Okay, now directly we go towards second chapter, that is your design of the compression members. Then what is design of compression members? There are several cross sections used in the problems. Okay, while starting we have first one is like angle sections. Okay, this is your angle sections, it's like these, some angle is there here, okay, here like that. Next is your circular section, next is your I section, next is your built up section. Okay, I section or circular section is like this. First only just simple circular section, again some hollow circular section, again you have some I section like this. Okay, you have two flanges, upper flange, lower flange and web. Okay, next we are having built up section with like this back to back connected. Okay, this is back to back connected, this is also back to back connected built up sections, and one more will be, it would be like this. Like this. Okay, so it would be like that. Then next we see some compression members. In that we have strut and post queen, like that. Some terminologies are used for solving. But while solving, we will understand very easily how to design the compressive members, compressive strength of the any structure, column, anything. Okay, in this system. Okay. So then next we see the effective length of the column or anything for designing. Okay, how we consider the effective length? Effective length is considered as per the IS 800 2007 from your table number 7. Okay, from table number 7 it can be considered. Okay, so next we see effective length of the column while designing the problem. Next we see the effective length of the column while designing the compression member. So KL, it is indicated through KL. Okay, then you can, where you can find this one? You can find this in table number 11 from IS 800 is to 2007. Okay, from table number 11 IS 800 2007. Next we are going towards the buckling class. We completed our effective length. You can find it in table number 11 from IS 800 2007 code book. Okay. Okay. Next we go for buckling classes. There are 4 buckling classes generally. Okay. Buckling class A, buckling class B, buckling class C, buckling class D. According to the imperfection factor, we can consider it from IS 800 2007. Okay. The buckling classes you can find is in the table number 7, mostly in the table number 10. Okay, you can find the buckling classes in table number 10 from IS 800 2007. Okay, you can find the buckling classes. There are several buckling classes for imperfection factors, alpha, like that, something is mentioned. Okay, you can find in that code book. Next we go for the slenderness ratio. What is slenderness ratio? It is the ratio of the effective length of the column to the least radius of gyration. What is KL? KL is your effective length. Okay, effective length. This is the formula, guys, for the slenderness ratio, KL by R. In examination, define the slenderness ratio. Then write like this. The slenderness ratio is defined as the effective length of the column to the least radius of gyration is called the slenderness ratio. Okay. Next, what is R? Least radius of gyration. R is least radius of gyration. Okay, least radius of gyration. Least radius of gyration. Okay, in the table number, and this thing you can find in the table number 7.2. Okay, in table number 7.2 of IS 800 2007. Then after that, next you need to find the radius of gyration. How you can find that radius of gyration? There is a formula for the radius of gyration. Moment of inertia by area. Okay, I is your moment of inertia. Moment of inertia. A is your area. Then you find the radius KL by R. Then KL you find in the effective length in the code book as per your table number 11. Then next you go for the radius. You need to remember the formula for radius. Radius is equal to under root of I by A. Under root I divided by A. I को A से divide करने से आपको R निकल आएगा. R क्या है? Least radius of gyration. Radius निकल आएगा, ठीक है? Least radius of gyration निकल आएगा. Radius मतलब circle is like this, so total radius would be come out. Okay. Next you are going towards R minimum, least radius of gyration. Okay. अब least radius of gyration का formula क्या है? Least minimum I minimum by A. Okay. This is your next we see some the design procedure for the design compressive strength. The design procedure, the design compressive strength. Okay, this would be the some provisions. You see the procedure how to solve the design of compression members. Okay, procedure to find the design of compressive strength. Okay, procedure. Now in the procedure, first we see the calculate effective slenderness ratio is equal to KL by R. What is KL? I told you the effective length of any member and R by R. That R is nothing but the least radius of gyration. K. Second point, K is based on the end conditions from table 11 from IS 800 2007. From IS 800 is to 2007. 800 2007 you can find the K value in the end conditions of column. Suppose it is restrained or fixed or pinned both ends like that, something there is 0.65 L. Some end conditions are mentioned in that code book. According to that, you need to interpolate each and everything using that conditions. Okay. The next third point is your R. What is R here? R is based on I and A, moment of inertia and area. Okay. Third point. This R is based on the moment of inertia and area. Okay. Next fourth point, R is equal to I minimum by A. That is a formula for the least radius of gyration. Okay, I told you. Then we find in fourth step we find the R is equal to I minimum by A, and I minimum depends upon the IXX and IYY. What is IXX and IYY? X and Y axis, whatever is acting is depends upon the I minimum. Next we are going for fifth point, that is nothing but your A, that is cross section area from steel tables. Steel tables is very important, guys. He will mention in question some sections like ISMB or light sections or heavy sections, ISMB, ISJB, ISLB, like that some sections are mentioned in the questions, or we need to design the sections using the steel tables in any examination or semester point of view. I am talking for students. Okay, so for the sections, choosing the sections, safe sections. Okay, for safe load sections we need to use steel tables. So this was the fifth point. For cross section area from steel tables we need to refer after the finding the R. What is R? Least radius of gyration. Then fourthly we need to interpolation. We need to do interpolation to find FCD and FY, yield stress and design compressive strength of any structure. Next, eighth point, it is a final step. You need to find the PD is equal to FCD into AE. FCD into AE, PD stress को हमें find out करना है last step में. तो जब हम problem करेंगे, when we will solve the problem, we will understand it very clearly. So this was the steps before the problem you need to apply in the problem while calculation of problem. So this is the procedure you need to follow in the 8 steps. Okay. So now I hope everyone is having their IS 800 2007 code book and steel tables. Please maintain while I am explaining the problem, and please copy down this procedure or take a screenshot while I am explaining this problem. Okay. So this was the procedure to find the compressive strength of the column. In today's session we seen this step, and next module hence we will see the how to solve the problem on any given section for the design compressive strength. Okay, we will see anything while solving in the next module. Okay, with neat explanation, and I hope all students to maintain the notes while explaining the design of steel structures concept. Okay, so this was some few points and fundamental knowledge to you for the design of steel structures. Then meet you in next session, guys. Until then, Allah Hafiz, and I hope everyone is getting some information from the video. Please subscribe the channel Civil Engineering 24/7, and meet you in next session, guys. Everyone, Allah Hafiz.